Okay, so maybe you're thinking, what's left to know about constructors? Let me encourage you not to skip this video. Maybe you were surprised to learn in a video in this section that you can create private or package constructors and that doing that prevents classes from extending your class. Perhaps you didn't know that using a final modifier on your instance fields is going to force you to assign a value either in a constructor or in another code block I haven't covered yet, an initializer. These topics are a bit more advanced, and now that you've mastered the basics, it's time to look at these additional features of Java. In the next couple of videos I'll be covering initializing final fields, initializers both static and instance, record and enum constructors. I've created a new project called Constructors Project with the usual main class in dev.lpa. I'll create another class called Parent. This is all I need to create an instance of this class, and I'll do that in my main method. I have a new object, not particularly useful, an instance of the parent type. Maybe you remember that Java has created an implicit constructor for me, the noargs constructor. This invisible constructor is actually quite important. Let me show you why. I'll create a child class and I'll put this in a different package, external at the root level. I'll have this class extend the parent class. This class compiles, and again I'll create a new instance of this child class in my main method. The point here is you don't ever have to create a constructor to instantiate a class. It's only when you start doing so that it gets complicated. I'll add some fields to the parent class. I'll make them private, so name and date of birth, or DOB for short, both strings at the moment. I'll add getters and setters for both fields. I'll also include a toString method, selecting none for fields. I'll change the return statement to one that prints the name and date of birth. Now my objects are a little more interesting. If I go to the main method, I'll print both the child and parent. I can run this code, and you can see that the name and date of birth for both the parent and child have been initialized to null. I'll now make my fields final. Those two changes give me 4 compiler errors. First, I've got errors on the field declarations themselves. Second, I've got errors in my setter methods. This is a reminder that when you use final fields, you must initialize them. When they weren't final, they were initialized to null automatically, but now I can't run this code without specifically assigning values to these two fields. I also can't ever reassign them, so these setter methods, which do that, aren't going to compile. First, I'll remove the two setter methods. I'm next going to add a code block directly after the declaration of these two fields. I'll assign the name John Doe to name. I'll set date of birth to January 1st, 1900. Before I talk about this, first notice how this eliminated my compiler errors, and I can run my main method. My parent and child now both have those values in their fields. What is this random block of code thrown in at the class level like this? This is an instance initializer. An instance initializer is a block of code declared directly in a class body. This code gets executed when an instance of the class is created. Instance initializers are executed before any code in class constructors is executed. You can also have multiple initializer blocks. They will be executed in the order they are declared. I'm going to now add a constructor to this parent class. I'll include that after the initializer block there, and I'll generate it selecting both fields. Note that this constructor has an error on both assignments. Hovering over name, you can see it says name might already have been assigned to. That's because it was in the initializer block. I'll comment out both of those assignments in the constructor. I'll next include a statement to the console in the initializer. I'll just print in parent initializer. I'll put one in the constructor too. This time I'll print in parent constructor. Getting back to the main code, notice that I have a compiler error where I'm trying to instantiate the parent class. What happened to my implicit noargs constructor? Don't forget, once you create an explicit constructor, Java will no longer provide you with the implicit one. If I want a no-args constructor now, I have to manually add it. Let me do that. Getting back to the parent class, I'll generate and insert it above the one with 2 parameters. I'll print that this is the parent's no-args constructor. Running this code now. What I want you to notice is that first, both the initializer and the no-args constructor were run. They were run for both the parent and the child classes. Importantly, the initializer block ran first. The instance initializer might be a good place to initialize default values, but it's probably not a great place to initialize final instance fields. By doing this, I can't now change those values in my constructors. Think about that for a moment. It's probably likely that's exactly what I want to do in my constructors, initialize instance fields from the constructor arguments. I'll comment out the 2 assignments in the initializer block for now, and I'll uncomment the ones in my constructor. I still have a problem though, a compiler error on my final fields. I can't assign values to the fields only in one constructor and not the other. The truth is, I don't really want that no-args constructor, so I'll comment that out. I'll get back to the main method and pass in data for the parent. But I have another problem, and that's with my child class. Let's go to that class and see what IntelliJ is telling us here. There's no default constructor on dev.lpa.parent. When I added a custom constructor, the implicit one wasn't generated, and I commented out the one I generated. Without it, we can't have a subclass that doesn't declare a constructor. Let me add an explicit constructor that looks like the one Java would generate for me, so this is a little easier to understand. This constructor has the same problem, but it's more obvious. Calling super with no arguments is the problem. Hovering over that, it says expected 2 arguments, but found 0. I'll pass some default values here, passing Jane Doe, and this time February 2nd, 1920. Now my code compiles again and runs. I want to add another field to parent called siblings, and I'll make this protected so my subclasses can directly access it. It will be an int, and I'll make it final. I don't want a setter because it's final, but I do want to add this to my one constructor. I'll add siblings to the parameter list of this constructor. I'll save the value passed to the constructor. This dot siblings equals siblings. Now I'll go back to the child class. I want 2 private and final fields on this class, an integer, birth order, and a birth order string. This class won't compile unless these final fields are initialized. Another way to initialize our final instance field is to call a final method. I'll create a private final method called getBirthOrder that returns an int. If the number of siblings is 0, I'll just return 1. Otherwise, I'll return a new random number between 1 and the siblings count plus 2, so that I get a number between 1 and the number of actual kids the parents might have had. Notice here I'm accessing number of kids, a field this class inherits from parent. I can access this field during construction or initialization because the parent's constructor is called first before this code is executed, so this field should be assigned a value by this point. I can now assign my birth order value to what I get back from this method. Now that I have the birth order, I want to set up the birth order string such as first child, only child, middle child or last child. I'll do this with an instance initializer block. I'll check if the number of siblings is equal to 0. If it is, I'll set birth order string to only. Now notice that although I have code setting birth order string in this initializer, I still have a compiler error on the declaration of that field on line 10, and the message is the same: birth order string might not have been initialized. Why do I get this when I have code to initialize it in this initializer code block? Well, consider what happens if the number of siblings is not 0. In that case, birth order string has no value, and since it's final, this is an invalid situation and the compiler recognizes that. I need to fully initialize birth order string by providing a value in all possible conditions. I could complete this with an else, but I want multiple conditions, so I'll continue. I'll add a condition to see if the birth order is 1, and if it is, that means this will be the firstborn, so I'll set birth order string to first. Again, I still have the error because I used else if there are still other possible unmet conditions. I'll continue with the rest of the conditions. If birth order is equal to the number of siblings plus 1, then this means the birth order string should be last. For any other condition, this must be a middle child. Note that when I added that last else condition, the compiler error was resolved. I want to add a println statement in this initializer code. I'll print that this is the initializer code in the child and print the birth order and the birth order string. My constructor now needs to include a number for siblings, so I'll change it. In the noargs constructor, I'll pass 5 as the number of siblings for Jane Doe. I want to include a println statement as well. I'll print that this is the child constructor, and I'll add a toString method. I'll replace the generated code, returning super.toString and concatenating the birth order string to that. Getting back to my main method, I have to include the number of siblings for the parent instance, and for that I'll just put 4 in there. I'm going to run this code several times now so you can see the randomly produced results. I want you to notice a couple of things. The first 2 statements were generated when I created the parent instance. The next 2 statements were generated when I created the child instance, so the parent's initializer is called, and then the constructor. After this, the child's initializer's code is executed, and then the code in the child constructor. The child initializer was not called before the birth order initialization though. Any assignments that occur before the declaration of the initialization block get assigned before that block is executed. I can confirm this because I was able to use birth order in the initialization block code. I'll move that code by cutting it from line 9 and pasting it on line 29. Notice the compiler errors I'm getting in the initializer block on this field. If I hover over one of those, it says illegal forward reference. I can't reference a field that hasn't been initialized in my initializer block. I'll undo that change, putting the birth order statement back on line 9. In addition to an instance initializer block, there's also a static initializer. This block of code lets us initialize static variables and is called as part of the class construction. Hopefully you'll remember there are no static constructors, so this is a way to include code you want to occur while the class itself is being initialized. I'll add a static initializer to the parent class. The static keyword is very important and the only differentiator between a static initializer and an instance initializer. I'll just print out that this is the parent's static initializer and the parent class is being constructed, running the code with this addition. You see that statement was only printed once just before I used the class for any reason. A static initializer is called the first time a class is referenced or constructed. A class can have any number of static initialization blocks. They can be declared anywhere in the class body. They're called in the order they appear in the source code. You might use this to set up some environment data or log information that's related to the class before it can be used. Remember, this will get executed only during the class's construction and not each instance's construction. Okay, so in this video I have covered final fields, initialization of final fields, and the use of instance and static initializers. You've seen that the noargs constructor is implicitly created only when an explicit constructor isn't declared. In the next video, I want to talk about record and enum constructors. See you in the next video.